So let's talk a little bit about join concepts. So relational databases, again, these are related tables. They are related tables that are developed based on normalization. Once we've normalized those tables, we're able to have our data sorted out in such a way that it's easy for us to query. So the way joins work is that we're going to update the from clause. Similar to our order of operations, the from clause is usually the first thing that runs. So at this point, we're going to make changes to the from clause so that we create virtual tables. When we join two tables, we're going to join them based on a common column per se. So think about sets. When you have sets of data, maybe you have a set of students in one school and a set of courses in another school. You go ahead and check which students are taking courses here, which students are not taking courses, and so on. So you create a virtual table based on those two tables that are matching. So if we understand sets, it should be easier. Cartesian product, again, just has to do with if you have two values in one table and 10 values in one table, the Cartesian product is going to be 20. So if you have two students and 10 different dishes, if you do a Cartesian product of the two sets, in that case, every student will have 10 dishes. So those two students will end up with 20 dishes of food. And that's necessarily not what we want when we are doing our joins. So we need to be able to have a foreign key that is related to a primary key. So let's check out a few examples. Again, joins, again, picture them as, let me make this bigger. Picture them as sets, right? As you look at this Venn diagram, an inner join, which you see right here, is an intersection of the two. So for instance, if you look at this query, you're selecting the first name and the amount from the order table. Here you're joining the sales. You give it an alias of the sales order as ORD. You're joining it on, or you're joining it with the employee table on a common column. The common column in this place is the employee ID. So whatever employee has placed an order is what we are going to see. If you have an employee that has not placed any order, they are not going to show up. If you have an order that was not placed by an employee, it's not also going to show up. It's only going to show you the matching records of both employee and order or sales order. Outer join is different. Outer join includes all the records in one table and then the matching records in the other table, depending on if it's left or right. Left or right joins are really interchangeable. It depends on how you write it. The name of the table that you write to the left or that you write first becomes the left table. The name of the table that you write on the right becomes the right table. So more or less, you would hardly see right joins, right outer joins out there. It's very, very less popular because most of the time we read from left to right. So if you're going to join employee table and order table and you want to use a right join, you might as well just flip the two of them. Flip the two tables and then use a left join. Sometimes, it's problematic for others to use it. A union is just, a full outer join is just a union. You're pulling everything together. So it doesn't really get used often as well. But there are some cases where you might need to just get all the data and look at it in one go. Okay. So the most popular is the left outer join. You also notice that the inner join is a default. So if you have a query that's written in this form with just join, that means you're talking of the inner join. Meanwhile, when you're talking of left outer join, right outer join, most of the time the outer word is omitted. So it just becomes a left join or a right join, just like the inner is omitted and it's just a regular join. Okay. So a quick example, left join, you have a from clause, the join clause, and then an alias for the table. That way, when you get to use it in a select clause, you can actually identify the columns with that table, and it's not too long. Because think about it, when you have to add the database name, the schema name, the table name, and then the column name, it's gonna end up taking the whole line of code. So you want to use that alias so that it shortens your code and it looks a little bit succinct. The on clause is what you use to identify the matching columns. In some cases, you might have to join more than two tables. In other cases, you might have to even join more than two columns together, per se. Yes, so I was saying that we use aliases, as you can see here. When you go to the from clause from HR employee as EMP, that's the alias that I'm going to use for emp.firstname. And you can also have multiple joins, multiple on. It's a composite join. For instance, if you have multiple columns that are identical or matching in both tables, it's rarely the case, when in some cases you might need it. So you might also have multiple joins. Maybe you take one table, join with another. Now you take that product and join it with another table, and so on and so forth. But remember, the order of the tables do not really matter in this case, because it's an inner join. It's looking at the intersection. So remember also the column names. If I go in and enter name in here, it might ask you the name, is it coming from the employee table or the sales order table? So make sure you use your full column names. As you see here, ord.amount is referring to sales order table amount. EMP first name is referring to the employee's first name. And that's what it will look like. So inner joins, again, they are the default. So you get to see them. You get to see them quite often. Left or right join. Again, you might throw out the outer word. That's just fine. But an example of a left joint here, you'd see every employee would be shown. The employees that don't have any order placed, they're going to have null values. The employees that have orders placed, you're going to see their orders right next to their name. So you can join the tables. Again, you can have more than two joins and so on. So be very careful with the order of the tables in this case. The order of the tables does matter. So if in this case, the left table is the employee table, the right table is the sales table. So all employee records are being included. If we want to do a right join, all we have to do is just flip this over. Now it might become sales order as ORD, right join, employee. So it's telling you that include everything from employee and only include a matching sales order from the sales order table. So that's why it's not very popular to use it. Full joins, again, like I said, is just pulling all the records in both tables like a union. It's not very used. It's not very intuitive because it takes up a lot of resources too. But cross join, like I said as well, is explicitly just a Cartesian product. So for instance, this example is a cross join. You're actually looking at the first name and the product name. So it's going to give you, if there are 20 employees and 100 products, you're going to end up with a virtual table of 2,000 records, which is not necessarily what you might need. And since you're using a Cartesian product, you don't need that on clause. The previous one, let me go back one. We had an on clause because you have to show the common columns. But in this case, for cross join, we don't really need common columns, so we just omit that. But the uses again for the full join, for union. Cross join is really used to generate data. So if you want to generate data for testing purposes and so on and so forth, large volumes of data, just take 100 customers and 2,000 100 customers and 2,000 records or 2,000 products, you end up with 100 or 200,000 flyers that you might go and show out there or send out to your customers. They probably will not be very happy with you. Okay, so self-join again. Think about having a table, an employee table, and in the employee table, you also have managers in there. So you might want to be able to identify your employee and your managers, something like that. But that's about it. There isn't that much else to talk about with joins. Now, what are built-in functions? Built-in functions, there are actually quite a lot of them, about 200, actually a lot more than 200, yes. But you can categorize these. These are either going to be scalar functions, functions that come with SQL server per se, and scalar functions operate on a single row, and they also return a single output. We'll look at that in detail later on. We also have logical functions, which actually compare multiple values and return an output based on the value that has been checked. Ranking, again, is going to operate on a set of rows, creates a kind of partition or a group. So we'll look at that in detail. But finally, aggregate functions operate on one or more, but will return just a summary, single value. All right. That said, let's look in depth on scalar functions. Scalar functions, like we said, they're going to return just one single value. So it also works most of the time on a single record or a single row. But our function might either get no input, meaning there is nothing that needs to be entered in the function. For example, if you look at the getDate function, it has no input, right? But in other cases, you might have one input. If you have one input value, there's an example of using upper. The upper function is going to take a text or a string or a single letter and return the uppercase of that letter. Likewise, lower is going to give you lowercase, depending on what you're trying to achieve. Also, in some cases, it might take in multiple values. For instance, the round function is going to take in a particular value, be it a decimal, and decides to round it to a number of decimal places. But you want to remember that anywhere that you can use a single value, you can also be able to use these scalar functions. You can see a bunch of examples here to the left, and we'll talk about this in detail later. But just the scalar functions, again, scalar functions are just a subset of our built-in functions. We have over 200 of them. They are usually divided into many different categories, as you can see in here. I'm not going to read them all out, but on the top left, you see the example date time functions. You can actually take in a date time value from your column. Remember, our columns have data types, and you can decide to pull just the year and give it an alias and say that's the order year. You might decide to put the day or a date name. Date name is a very fun function that we're going to exercise in our lab. In this case, when you type in it's expecting you to enter, or the output is going to be a month, which is going to be 2 decimal places. DW is going to be the day of the week. YY is going to give you the date, or rather, date difference is going to give you the difference between the order date in this case and today's date, which is get date. In this particular case, we're using a nested function. So we'll talk about that in detail. You're having a function within a function. So this actually runs first. You get today's date, and then you find the difference between today's date and the order date. But what we only want to focus on is the year. That's why we have YY. And that's going to give us the years since our order. All right. So that's just an example for a date and time function. Likewise, we can also have mathematical functions. As you see in here, we can get a tax amount. We can round it to no decimal place, so it's just rounded to the highest value. Or we can floor it. Floor it is actually rounding down, while ceiling is rounding up. But again, we can decide to round to a particular digit based on the value that is entered in the second argument. Also, we can use a square to multiply it by itself. We can use the square root to find if it's the value that you need to multiply to by itself to give that value. I can find a logarithmic. So you might also want to randomize it. RAND gives you a random number, and you multiply that random number with your tax number to make it randomized. So those are some of the mathematical functions that we can use, mathematical scalar functions, I should say. Also, we could be able to use string functions. Those are quite enormous, quite a lot of them. In this case, you see the company name will be put in uppercase or in lowercase. We can decide to find the length of the company name. If it's ABC, then we know the length is going to be 3. We could reverse it, so if it's ABC, it becomes CBA, and so on and so forth. So you get to decide or find the character index. For instance, find the first space within the company name, and it's going to tell you if it's the boy, then the first space will probably be in the fourth option, the fourth index, or should I say the fourth occurrence, which will be the third index since it's 0-based. Also, you can look for substrings, you can look for the left section of the word, and so on and so forth. So all of this, again, is well documented in Microsoft documentation, which we're going to take a look at in our lab. Okay, sounds good. So that's it for scalar functions. Next up, we want to look at logical functions. Again, it's basically talking about logic, right? We get to determine what value needs to be returned based on the evaluation of an expression. But it depends on what kind of expression you're evaluating. If it's a Boolean expression, we talked about Boolean before. Boolean is either true or false, yes or no. So we give an expression, we evaluate it. If it's true, we return a particular value. If it's alternative or if it's false, we return another value. Just like we will be able to pass in an integer to be evaluated, right? So again, data types, if you know your data type is an int, we evaluate it. And we use the choose function, the choose logical function in this case, to be able to see. Here are some examples you see on the left. For instance, we're going to select the address type, and we check if the address type, if the value of the address type says main office, then we're going to say we should return billing. Otherwise, we're going to return that column as mailing. That's what is going to be used as the column header. All right. So again, it's checking this column address type. If the address type has main office in there, it's going to return it as billing for this column. Otherwise, if there's no main office in there, if it's typed differently, for instance, if you have 3 Fs instead of 2 Fs, then you end up having it as your mailing address. Now, if we took a look at the choose function, here we're choosing the status. We know for a fact that the status of 1 means that the sale or the item has been ordered. If we change the status to 2, it's been shipped. If it's changed to 3, it's been delivered. So we can have a column that holds that value. If the value is 1, 2, or 3, that's what's going to be returned. So again, we're going to look at a few examples of those. Just remember, choose is going to evaluate an integer data type, while if it's going to evaluate a Boolean expression. All right, awesome. Let's proceed to the next type of function, ranking functions. Again, the input here is a set of rows. So for instance, we have list price. We're going to pass in the list price, and the output will also be a set of rows. And it's being used in many different cases. For instance, it's ranking offset. I think we looked at offset earlier. We'll also be using it in aggregates and distributions, which we'll probably not touch that much. But the ranking performs a calculation against a defined set of records. For instance, if you look at the example to your left, we're selecting the top 100 product IDs and names with the list price. We would like to rank it, and we're ranking it to order it by the list price in descending order. So it's going to rank the highest, most expensive item would be number 1. If there's 10 of them, all 10 of them are going to be number 1. and then the next item will also be listed thereafter. So that's how you'll be able to rank your products to say, okay, these are the expensive items, these are the least expensive items, and so on. In this case, we're ordering in descending order. In addition to that ranking function, you can have an over clause, which you do see here. Here, the over clause doesn't really have any addition to it, but you can also define partitions or groups, as you see in this example. Here, we're partitioning it by the name of, C here corresponds to category. So we're looking at categories and the list prices. So we're breaking it by category. So the category of household items will have its own ranking. The category of sports items will have its own ranking. The category of food items will also have its own ranking. That's why we're partitioning it by the category in this case. All right. Awesome. Let's proceed and jump into aggregate functions. Aggregate functions are very popular. All right. And you see at the bottom, the common aggregate functions I would see is count, which we probably use often just to check the number of items that we have in a particular table. We also have minimum, maximum, sum, and average. Okay. But what we need to remember here is the input is multiple values. The output is a single result. So we also might be able to nest them, which we'll talk about. But a few guidelines. You cannot use it in a where clause. You cannot use an aggregate function in a where clause. You're going to experience or encounter an error. Also, you want to understand that null values are always going to be ignored. So if you're summing values, it's going to ignore the null. But in the case of a count, you do not ignore the null values. So if you're counting the records, it's going to count every row, whether the value is null or not. But you also want to remember that when using these aggregate functions, the columns usually have no headers. So it's a good idea to use aliases to make your columns be more descriptive of what exactly you're doing, because it's just going to say column 1, column 2, column 3, which is not very intuitive for us. And when you're using aggregate functions, very, very important that the columns in your select clause must be included in the aggregate function itself. So as you see in some of these examples, we're able to get the average list price, the minimum list price, and the maximum list price. But we're also using aliases to be able to explain to you what each one of these values are. Also, you might go ahead and use minimum, maximum on a text value or a string value. It doesn't have to always be a number or numeric. In this case, we're using it to check the numbers or the names of the company. If the company's name is ABC, it's probably going to be minimum. If the company's name is XYZ, it's probably going to be maximum. All right. Also, in the case of nesting, we're able to use the date time function of year to be able to pull just the year for our order date, as you can see in this case, the very last example. But then, once we've gotten those years, we would like to also check the minimum in the first case or the maximum in the second case and return them as the earliest or the latest orders that were placed for us. So that's how you go ahead to do a nested function. Remember, the innermost function gets evaluated first before the outermost function is evaluated. All right, very good. Now, following our aggregate functions, it's always a good idea to group your content. Okay, think of a pivot table when you have those different groups. So again, a group by clause is used to subdivide your output into groups of rows. Very similar to a distinct, as you see at the top here. If you select just a customer ID from your sales order header table, use the group by clause, it is pretty much the same as just saying select distinct customer ID. Why would you want to use one over the other? You would probably want to use a group by clause if you need to add an aggregate function. For instance, in the next case, if we needed to add a count of all the orders for a particular customer, then you definitely need a group by, and a distinct would not work in that case. So with a group by, you can then have a very well-designed table or output that will show you all your customer IDs and the number of orders that they have had for each one. All right. In addition, you could also use an order by clause. The order by clause would then be able to help you order your output, because obviously there's no guarantee that SQL is going to give you in the output in the order that you need. But a few things to remember. We talked about order of operations earlier. Even though it's written in this format, you know that the from clause gets executed first, and then you group your stuff, and then you select, and then you order it by after you've gotten the output. A few things to note when you're also working with the group by functions, you might run into some errors. Common errors would be if, for instance, this is going to run perfectly fine because I'm grouping by user ID and purchase order number. But if I remove any one of these, I can probably I will definitely run into an error, because it's going to tell you or complain to you that you cannot have a column in your select clause if it's not included in your group by clause. So you have to be careful of those. It's either have to be in your group by clause or it has to be in an aggregate function. Okay. But if you have this as an aggregate function to say maximum purchase order number, then it should work just fine if we take order number out from this case. All right. Let's take an example again, or let's look a little bit further at, in this case, filtering those groups. So think about the where clause that we looked at earlier when we were able to select a table, or should I say, look from a table and select records. We got to get the entire table, and then we use the where clause to filter. In this case, we are filtering groups. Okay. So the having clause acts as a filter on groups, very similar to our where clause. So for instance, if you look at this example again that we looked at recently, looking at all the customer IDs and their orders, or number of orders that are placed, we can go ahead and add a having clause, which will say if the count is greater than 10, then we want to include it in our data set. If the count is not greater than 10, then it's going to be discarded from our data set. But in some cases also, you could have the where clause and the having clause. If you have both of them, you need to remember that the where clause is going to be executed first, because it's going to filter the information for each row, and then your group by is going to be processed, which would then group all your records together after they've been filtered. And finally, you have your having filter that's going to filter the groups based on the output. So having usually looks at the result of an aggregate. We need to keep that in mind. Awesome. And that said, I think we probably covered everything that needs to be talked about. Again, functions, a few things that we need to remember. The documentation is out there because we definitely cannot exhaust every single one of them. We could have scalar functions, for instance, date, string, and math functions. We could also use logical functions. We'll talk about is numeric in our lab, if and choose. And finally, you have aggregate functions, for instance, count, average, minimum, maximum, and so on and so forth. Group by is very useful when we want to aggregate our results, and having is also very useful if we want to filter the groups of records that we've outputted. A few challenges for you. We'll expect you to, before we get into our challenges, just a recap. We talked about categorizing those built-in functions, how to use our functions and scalar functions, ranking functions, aggregate functions, and summarizing our data with group by, also filtering our data with, or filtering our groups, I should say, with the having clause. That said, we should now be able to proceed to exercise a few challenges, which I'm going to send a video for that. A few things to point out: we retrieve order, shipping information, as well as aggregate some product sales information. All right. That said, if you have any questions, please do reach out, and I will do my best to answer all your questions. Otherwise, thank you very much for keeping up, and I hope you get to enjoy watch the demo of our challenges and a few of our examples as well, just to, remember that practice makes perfect. The more you practice, the more you know, the more mistakes you make, the more you learn. And yes. So a subquery, as you can see, is a query within another query, similar to what we see here at the bottom right. Okay, this inner query and the outer query. So the inner query provides its results for the outer query to be able to look at it. So it depends now on the nature of the results that are coming from the inner query. If the nature of the result is just one value, then we are looking at a scalar subquery. Otherwise, if the nature of the result is a multi-value subquery, or sorry, if the nature of the result is a single column, right? A single column table, or just a single column, or just a set of records per se, then we're talking about a multi-value subquery. So it's not a big deal. That's about it. But then you have two types of relationships you can have between this inner and the outer query. If the inner query and the outer query have no dependencies, then we're talking about a self-contained subquery, which is what we'll be seeing in a little bit. Otherwise, if there are references between the inner query and the outer query, then we're talking about a correlated subquery. It's no big deal about it. That's all we have to do. That's all we have to talk about. So let's dive into each one of these. A scalar subquery. As you can see in the very example on the very first example on the top left, we're using the max function to be able to get the maximum number for the sales order. So the sales order ID, again, it's an automatic number that is going to be generated for each record when you make a sale. So obviously the highest number would be your most recent order. So with this query, you're just getting the highest number for your most recent order. Now, this query can be used as an inner query, which is what we see in the second stage. We're using that as an inner query. It's going to give us one value, one number, which is going to be our most recent most recent sale order. So when we do that, we are able to go ahead and say where sales order ID is equal to whatever was returned. So that is how you create a subquery, which is a scalar subquery. We are now able to select within the sales order detail table to get the order ID, product ID, order quantity, and that's it. No big deal. Also, you may have that inner query located in anywhere or any different location in your query per se. You can set it in the select part, in the from clause, in the where clause, even in the having clause, which we haven't talked about yet. So you can also use it in update and delete, which we haven't talked about yet. We'll talk about it in future, but here's an example of using it in the select clause. So we're selecting sales order ID, product, order quantity, and we're also selecting the average of the order quantity, which is going to be displayed as average quantity. All right. So this gives you an idea of using subquery in a select clause or in a where clause. At the end of the day, you have a few guidelines that you need to remember. The use of parentheses, you really want to make those parentheses in there because that tells you that that inner query gets executed before the value is handed over, or yes, in this case, the result is handed over to the outer query for it to be executed. So it's a use of multi-level subqueries. You could also have queries within queries within queries, but we don't need to get that complicated. Just to understand that that possibility is out there in case you see it. Just start from the innermost query and work your way out. All right. So also you want to remember handling null values in your inner query. If your inner query spits out a null value, then you're going to get no results, right? But if your inner query is not set up correctly and you end up returning more than one value, then you have an error message. You're actually working in this case with a multi-valued subquery. Sounds good? Awesome. So let's jump into multi-valued subqueries in that light. Again, like we said earlier, in this case, you receive multiple results, multiple rows or multiple records in your output of the inner query. So what we need to remember, first thing is you use the in operator. We talked about the in operator earlier. Rather than having multiple or clauses, you use an in, and everything within your parentheses separated by commas are used as input. So here it returns more than one row, your inner query that is. For instance, if you look at this inner query, it says select customer ID from sales.customer, where sales is the schema, customer is the table, where the country region is Canada. So we're going to have more than one possibly customer in Canada. So we're going to have a list of customer IDs. Those lists of customer IDs will be returned, and they will now be within this in clause. So we're going to look for customer ID and sales order ID for all the customers in Canada per se. That's it. But you have to remember again, inner query returns one column, of course, column ID, but it can return more than one row. All right. But multi-valued subqueries in general can be easily written as joins. Okay. So it depends on you. When do you want to use a join over a subquery? Because this subquery at the top left is exactly the same as the subquery at the bottom left. Again, we're just joining two tables, customer table and the sales order header table, which you see as C and O. And we're making sure that we're pulling only customers where the region is Canada. All right. So it depends on you. What columns you need. If you need columns from both tables, then you need to use a join. If you need columns from just one table, you can use a multi-valued subquery. But you want to be able to use a multi-valued subquery in some cases to start building your joins, because you are able to break down those steps. So an experienced SQL query developer will probably just jump into the join and understand what they're doing. But someone who is still a novice or still working their way up might prefer having subqueries to actually see the steps that are being executed before getting to your output. Sounds good? All right, so let's jump into self-contained versus correlated. Like I said earlier, self-contained subqueries are the ones that have no dependencies whatsoever, okay? But correlated subqueries reference one or more columns within the outer and the inner subqueries, queries per se. So a few things to note: correlated subqueries are executed together with the outer query. That's the inner query per se, but it complicates testing and debugging, so it's not really very popular. And here's an example though of one that we'll look at. Let's start again with our inner query. We are selecting the maximum sales order ID from the sales order header table. And we are using a relationship here where the sales order header table, which we have here as O2, is related to the sales order table, which we have up here as O1. So that is a relationship that we have between this inner query and our outer query. Okay. So again, once you have a relationship, in this case in the where clause that specifies that this should be tied to the other table, then we're looking at a correlated subquery. A few things to point out: we could use the exist, working with exist to check to see if there are any rows in the result. Remember that we talked about handling nulls earlier last week. So handling nulls, we want to be able to check, if there's any record that's going to be returned or not, because those null values or those null results are going to always mess up our query, and we might end up having some results that we don't expect, or having an error message in some cases. All right, a few things to work on. We're going to take a look at simple subqueries, trying to find products with a list price higher than the maximum selling price. We'll work our way slowly and surely through that. And also find names of products that have been ordered in quantities of 20 or more. Remember, in this case, we want to use subqueries, but we can always convert those subqueries back to joins. And in addition to that, we'll also look at correlated subqueries and retrieve some company information, in this case, company name, for each customer using a correlated subquery in a select clause. Sounds good? All right. Before we start with that, what questions do you have? Whatever questions you have, reach out to me and we'll be able to answer those. So quick recap, very sweet and succinct. Subqueries, understanding them. We've been able to understand it so far. The use of scalar subqueries, returning one value. The use of multi-valued subqueries, returning one column of records. And self-contained subqueries, the ones that don't have any relationship between the inner and the outer queries, and correlated subqueries that are related in terms of inner and subqueries. That said, since you're going to reach out with me with your questions, I'll go ahead and share with you the challenge. Thank you again, once again. The challenge for this week would be